Hey, what's up, guys? Okay, so in this video, that that I want to talk about the complexity class, interesting complexity class called P slash poly. Okay, and basically, okay, so there are two kind of definitions. So in this video, I just write down definition. Maybe in the future, one can prove that they are the equivalent. So one is that c to the so you take all the integer and then take all the sides to the n to the c. So side this is the n to the c polynomials n to the c side circuit. Okay, so the size of circuit is just the number of gates, and all the gates that we are able to use should be like and or just not gate. Okay, and this is one kind of definition, and okay. So another kind of definition is, I guess, from my perspective, I think it's like more like more more interesting is like called advice. Okay, so the idea is that you can define t and a, let's say two functions from integer to integer, and then one can say that one can define time of, right, so you get deterministic time, let's say t of n slash a of n, right? So this means that this is the language that decides by Turing machine. Okay, so this Turing machine has two inputs. Let's say call M, right? Has two inputs. One is x, one is a string called alpha n. So alpha n is given given the n integer, there's a particular string, and then let's say alpha n is at most is length of a n. Okay, and such that and x belongs to L, then you can just once somebody gives you this advice, then you can just compute in polynomial time. Okay, so it basically means that this alpha n is like somebody gives you this alpha n, and you can just compute. Okay, and notice that the important definition is that alpha n is independent, independent from x. So it's like different from NP, right? So in NP, that somebody gives you a x belongs to L, there's a polynomial size certificate, polynomial length certificate that's such that your Turing machine run MXY output 1. And then in this case, this alpha is uniform, right? So somebody give you a particular string, this string is so weird. Once you take this string, then you can compute. Okay, and by the way, and also remember it's run in Tn steps. Okay, and then you can define p slash poly by just by the same definition. So you just union of basically all this. So such that n is this is polynomial up any, and this is also polynomial. Okay, so this will give you the definition. Okay, and there are many like kind of like theorem about this p slash poly. Like something is in the p slash poly, then hierarchy collapse, that kind of statement, and maybe talk in the future video. Okay, but the rest of the video will prove that one simple implication. So fact, or basically theorem. Basically BBP is a subset of P slash poly. Okay, and this is interesting to, I think the proof is very interesting. So I want to go through the proof. Okay, so idea is very simple, right? So remember that X belongs to BBP. Basically, there's a polynomial Turing machine, right? So this probability Turing machine which take a random input. Let's say let's force that this random bit string is that's 2 to n, right? So and the x is, let's say x is 2 to n. X length is n. Okay, so probability that R belongs to 0, 1 to n, then n for Rx equal output 1 is greater or equal to 2/3. Okay. And if X belongs to not belongs to L, then probability of R, like your probabilistic determinant machine should reject. Right? So output 1 with probability less than 1/3. Okay, and the idea is that you can use the majority votes, right? You can just run your algorithm for many times and just do majority votes. Okay. And then you can use the Chernoff bounds. I think you can use Chernoff bounds to improve this probability to be exponentially 1 over exponentially small. Okay, so this means that you can change this to be in polynomial time in 1 or greater equal 1 over 1 minus 1 over 2 to the 2 to the x, and 1 over 2 to the 2x. Okay, so it's basically 1 over 1 minus 1 divided by 2 to the 2n, and less than 1 over 2 to the 3n. Okay, so once you have this, then you are able to show this, right? In order to prove this, we need to find advice, right? So the proof idea is that we need to find advice for some n, for every n. And then notice that the advice need to be polysize, need to be polynomial in n. Okay, but this proof is already enough, right? B. Okay. Okay, so reason is very simple, right? So the reason is that we can define bad x, right? So bad x means that let's say x belongs to L, right? So bad x basically is R, such that your MXR is fails, right? So MXR gives 0. Okay, then by previous computation, the previous definition, right? That means that for every x belongs to L. So x is n, right? So at most 2 to the n input. So the probability of R, small r, the x, the probability R, right? You randomly choose R, and the R belongs to x is less or equal to 1 over 2 to the 2n. Okay. Right? You choose x, right? You choose x. You fix any x and you choose that R to be wrong, right? So R belongs to base x is very small. It's probability 1 over 2 to the 2n. Okay, so it's very, very small. Still there is a possibility, but okay. Okay. And right, okay. Okay, so that means something, right? That means that right, that means that if you take, so I can ask the following question. I can ask, is there R such that all the okay, so let's see. So at least, right? So I can ask the following. I can ask the probability of R, right, such that is this X belongs to bad R. Sorry, stupid. I can ask this quantity. I can ask. I pick R, right? I pick R, and I can ask whether there is this X such that X belongs to such that R belongs to bad X. So this is I randomly choose R, right? And I want to ask what's the percentage or what's the fraction that there is this X such that R belongs to bad X. And by union bound, right? So since for each X, the probability of R belongs to bad X is less or equal to 1 over 2 to the n. So I can say that. So what's the bound, right? The bound is very simple, right? You just take I just take 1 over 2 to the n, right? And times 2 to the n. The reason is there at most so many. This is the number of x, right? So the probability of there is this x such that R belongs to by x is less or equal to the is less or equal to this guy, right? Times 2 to n. Okay, because there are just so many. There is only 2 to the n x, right? So the worst situation is that is this kind of situation is that for it is x such that R belongs to x is x. right? So the worst situation is that since each x, you have 2 to the n, right? In each x is so this is just union bound, so it's bounded by union of summation of the probability of x, right? And R belongs to base x, right? Because in such case that this x at least have one contain some R, right? So as a set, this guy is just subset of this guy, right? And you take all the x, they give you this. So this is a union bound. Okay, but this is 1/2n. Okay. Okay, so it's less than 1. So that means that if you sum over R, the probability of R that R belongs to x and sum over x, and this probability is less than 1, so the fraction is less than 1. So that means there is a particular string R star, such that R star do not belong to any bad x, right? So R star is good random string, right? For all x, right? So R star is advice, right? Because by definition, their x R star is always 1. Always output is 1, always 1. Okay, for all x belongs to L. Okay, so we find advice. So this proves that BVP is a subset of P/poly. Okay, so the natural question is that one can ask whether an NP belongs to P/poly. And there's a theorem that if NP belongs to subset of P/poly, implies that the pH collapse into the second level. So this is a theorem that is interesting. I may prove in the future. See you guys next videos.